Hello friends, in today's question, a block of mass 2 kg is resting on a rough inclined plane of inclination 30 degree as shown in figure. The coefficient of friction between the block and the plane is 0.5. What is the minimum force F should be applied perpendicular to the plane on the block so that the block does not slip on the plane? So we have a plane and a block on which a force F is being applied, that is perpendicular to the plane, and the angle of inclination is given as 30 degree, and there is a coefficient between, rather we can say friction between the block and the inclined plane, and we are supposed to find out what will be the value of the minimum value of F so that the block does not slip on the plane. So first of all, let's find out the various forces which will be acting on the block and in which direction the block has tendency to move. So we can draw its free body diagram. So this is given 30 degree and we have block. So in the downward direction we are going to have mg, which can divide into two components. This will be also 30, so we have mg cos of 30 and this will be mg sin of 30, and there will be a normal direction n. So let's find out the force mg sin of 30, which will try to move the block in the downward direction. So in this case we are going to actually find out what will be the direction of the friction. Okay. So you can say for the calculation of direction of frictional force, let's calculate mg sin of 30. Mass is given as 2, g is about 10, and we have our sin of 30. Sin of 30 is 1 by 2, so we get this as 2 into 10 multiplied by 1 by 2, so this comes as 5. So we get this force as 10 Newton. Now let us find out the maximum value of the friction that can act on the block. So you can say that Fr max is equal to coefficient multiplied by normal. Normal is mg cos of 30, so this is mu mg cos of 30. We substitute the value. Mu is given as 0.5, mass is 2, g is 10, and cos of 30. So we get the maximum value of the friction Fr max will be coming as approximately equal to 8.66 Newton. Now if we make a comparison between the downward force mg sin theta and Fr max, we can clearly see that mg sin theta is greater than Fr max. The block has a tendency to move in the downward direction, as mg sin of 30 is greater than Fr max. Therefore block tries to move, or we say block has the tendency to move down the inclined plane. Therefore frictional force will act up the inclined plane. Okay, or here let me add one more thing. For the calculation of directional frictional force, or here we can see that whether block has tendency to move or not. Now in case the frictional force would have been on the higher side, the picture would have been entirely different one. So in this case the frictional force will act on up the inclined plane. So let us draw the free body diagram once again. This is our 30 degree. We have a mass that is going to have mg, two components. This will be mg cos of 30 and this will be mg sine of 30. We will have frictional force Fr in upward direction and there is a normal n and there is a perpendicular force F which is applying on the block. Now it is said that the block should not slip. Okay, you can say here from to avoid slipping of the block, the downward force or the component should be equal to the upward force. So you can say that mg sine of theta should be equal to Fr. Okay. Now for the calculation of Fr, now we have considered that the force F is also being applied on it. So from here we can say that our Fr will be equal to Fr plus F. One second. This will be mg sine of theta is equal to my mistake. So we can write this as mg sine of theta is equal to Fr, and let's find out the value of Fr. Fr will be equal to mu n, and the value of normal will be in this case equal to n will be equal to F plus mg cos of 30. So we get Fr as mu multiplied by F plus mg cos of 30. So let us substitute in this equation. We get this as mg sine of theta is equal to mu F plus, so it should be 30 not theta, mg cos of 30. So from here we can find out value of F. So F will be equal to, let's open the bracket, this will be mu and we have mg sine of 30 minus mu mg cos of 30. We get F as mg sine of 30 minus mu mg cos of 30 and divided by mu. So we can find out this will be coming as mg sine of 30 divided by mu minus mg cos of 30. So if you substitute the value, you get F as 2 into 10 into sine is 1 by 2 was 1 by 2, and this is 0.5 minus 2 into 10, and cos is root 3 by 2. So from here we can say that this is equal to, this will be coming as 20 minus 17.32. The force F that is required is 2.68 Newton. So from here we can say for this value of force applied perpendicular to the block, it will not slip on the plane. There will be no slipping of the block on the plane. This completes the question. Thank you.